Hi kids, now we'll be going with this first paper discussion. You can look into the first question. The first question says, the blocks A and B shown in the figure have masses 5 kg and 4 kg. The system is released from rest. Speed of B after A has travelled a distance 1 meter along the incline. 1 meter along the incline, right? So this is the figure. Now you can see, if block B up moves by distance x, then this pulley will go up by distance x. Then there will be this length and this length, which will be becoming slack, right? Now that must appear here. So if this goes up by x, then this will go down by 2x. If this goes up by x, then this will go down by 2x. Now that is the thing. Now what they said this will go down by 1 meter. So this will go up by half meter. So work done by gravity positive, and work done on this by gravity is negative. What is the work done by gravity on this? 5g sin theta into 1. 5g sin theta into 1, that is positive work done, minus negative work done, 4g into half, its weight is 4g, right? This is the total work done by gravity, that equals to change in kinetic energy of the system. That is, if I assume this speed as v, half into 4 into v square. If the speed is v, you have seen, like, if the speed is v, then the speed is going to be 2v. So if the speed is v, its kinetic energy will be this much, this kinetic energy will be this much, right? So that's the only equation you have to write. Work done by gravity equals to change in kinetic energy of both. So when you solve it, you will be getting v, right? Next question, a sphere and a cube of same material and same total surface area are placed in same evacuated space after they are heated to same temperature. The ratio of their initial rate of cooling in space is. So you know, if a body is emitting power, then its temperature will keep reducing, right? So energy is ms delta T, power is ms, the rate of at which it is changing, right? Now anyway, I have put negative because its temperature is going to reduce. Now what is mass? Mass is density into volume. Why I have taken that? Because they said same material, so same sigma value, same rho, right? Same rho. So when I modify it, the rate of cooling will turn out to be this much. All these are constants for both the materials. The only thing is volume is different. But what they said, surface areas are same. From here I can get the volume relation, right? Surface areas are same. So from there I will be getting volume relation. Now if I want to find the ratio of rate of coolings, when I use the right hand thing, then I will be getting volume ratio. Volume ratio I can find from surface area is same thing, right? From there you will be getting the answer as C. So here also it's more or less like direct question only, right? The next question, all electrons are ejected from the surface by incident light of wavelength 200 nanometer can be stopped before traveling 1 meter in the direction of uniform electric field. So what is happening? You are sending some light, then because of that some photoelectron is emitted, but what you are doing, while it is going this way, then you are trying to pull it back. So after traveling a distance of 1 meter, it is going to stop. So after traveling some potential difference, it will stop, right? So it is having some kinetic energy which is getting converted into potential energy. So this is the energy you are sending, 1240 by 200, right, electron volt, minus whatever is the minimum requirement, right, threshold. Out of this, some energy will be utilized to bring it out. Now after bringing out, what is happening, that kinetic energy, whatever is left over, it is converting into potential energy. How much is that potential energy? According to the given information in the question, electric field is 4 and distance is 1. So difference in potential is 4 into E volts, that is 4 electron volt. Electron volt on 3 sides will be getting cancelled. I didn't put it. So from here I will be getting the threshold value as 2.2 electron volt, right? The next question, the activity of sample radioactive materials is A1 at T1 and A2 at T2. The mean life is T. So you need to find the relation between them. So A1 equals to A0 into e power minus lambda T1. These two, this thing you must be knowing. So when you take the ratio, you will be getting the required answer. It's a direct question, and mean life they have given mean life. So lambda is 1 by T, right? Next question, a small ball of mass m is released from rest from height h above the liquid surface. The density of ball is rho by 3. So they are asking different options. Okay, I'll show the solution, then I'll read out the options. So for what height it will be able to enter the liquid of 2 rho. So suppose I'm just saying, like, what is the minimum height requirement so that it will enter here. Just enter here. So initial kinetic energy is 0, final kinetic energy is 0, I am assuming. So what is the work done by gravity? Work done by gravity from here to here is mg into this height plus this height. So mg into small h plus h by 2. mg into small h plus h by 2, that is the work done by gravity. It is positive, will be equal to work done by this liquid in the opposite direction, right, magnitude wise, or total work done equal to change in kinetic energy, total work done is 0. Gravity will be doing positive work, this liquid will be doing negative work, magnitude wise they must be equal. This is the work done by gravity. Work done by this liquid is buoyancy. Buoyancy is density of the liquid into volume of the body into g, right, buoyancy into what is this distance, h by 2. So total work done equal to 0. When I equate it, I will be getting this one. So from there I will be getting, this is capital H. So the minimum height needed is capital H. So option A is correct. Now going to option B, when it will sink to the bottom. So again I will be going with total work done equal to change in kinetic energy and what is the minimum requirement. So if I drop it here, finally it is stopping here, something like that. I mean minimum requirement, right? So work done by gravity from here to here, mg, I mean this is m into g into this distance h plus h by 2 plus h by 2. Work done by gravity will be magnitude wise equal to work done by this buoyancy, which is density into volume into g into this distance h by 2 plus work done by this buoyancy. This buoyancy will be density of that liquid into volume into g into, that's the buoyancy into h by 2, right. So work done by gravity plus work done by this buoyancy plus work done by the second buoyancy, total work done equal to 0, or magnitude wise work done by gravity equals to work done by both the buoyancies. So when you do that, you will be getting 7h by 2. So the minimum height needed is 7h by 2. So option B is also correct. Now if small h equal to, if small h equal to 0, option D, it will float on the surface. Yes, because density of the liquid is more, so it won't sink, right, it will float. So option D is correct. Coming to option C, if this is 2h, then while entering this part, its kinetic energy will be how much? Again the same thing, work done by gravity plus work done by this buoyancy equal to change in kinetic energy. Work done by gravity minus, buoyancy will be doing negative work, so minus work done by buoyancy equals to change in kinetic energy. When you do that, you will be getting change in kinetic energy at that crossing point will be mgh, which is correct. Going to the next question, an experiment measures quantities a, b, c and x and x is calculated from the given equation. If the percentage errors are something, so then the percentage errors can be what values. So this is a regular template, right? So you will be taking logarithm, you will be differentiating it, you will be getting something like this. Now if you want to see what is the maximum error means this error has to be positive, 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 right? So maximum error will be this thing, when this thing will become positive. So maximum error is turning out to be 13. So out of all the options, whichever can come below 13 can be the option, because maximum percentage error can be only 13, right? Going to the next question, two spherical bubbles, so bubbles in vacuum are connected through narrow tube, radius of left tube is r and that of right is slightly smaller than r. Now what is going to happen? This pressure will be less and this pressure will be more, because it depends on the radius of curvature, right? P inside equal to P outside minus plus 2T by R. So this pressure is going to be less and this pressure is going to be more. So what is going to happen? This air will be flowing into this bubble and this is going to become small and this is going to become big. But anyway, they are not asking much about exactly what is happening. They just asked, you don't need what is happening to solve the question. They are saying like number of moles, area, volume, okay, fine. Temperature is remaining constant, so the rate of change of N1 plus N2. Number of moles won't change, right? So first option is correct, it is 0. Rate of change of N1 plus N2 is 0 because number of moles are not going to change. Now they said same temperature, right? So at any time, like if I write the pressure here as P1, volume is V1 and all this, these things are given. So P1 V1 equal to N1 R T1. Now what is pressure inside? Pressure inside minus pressure outside is 40 by R, right? It is so bubble, right? So two interfaces, so 40 by R and outside I am taking it as vacuum to get the answer, right? I think they must have mentioned it nicely. So when you do that, you can see like N1 RT is proportional to R square, N1 is proportional to R1 square, N1 is proportional to R1 square. Similarly, N2 is proportional to R2 square you can get. So you can see like when you add them, it will turn out to be like 4 pi r1 square plus 4 pi r2 square. So that's like n1 plus n2 is constant, so a1 plus a2 will also be constant. Yeah, from there you can see option B is correct, a1 plus a2 is also constant. Now thereafter you need to find at the instant when the number of moles in left bubble, n1 is 4 times of n1 by n2 is 4:1 they said. So when you take the ratio r1 by r2 is 2:1, you will be getting 2:1. Now apart from that, what you know, total number of moles must be constant. So initially n1 RT is s into 16/3 into pi into initial radius square. Initial number of moles in the second one equal to s into 16/3 into pi into initial radius square, right? So what is the total number of moles into r into t? That is s into 16/3 into pi into initial radius square, that is 2 times, right? I can say this is the number of moles on the left side anytime, right side anytime, left side initially, right side initially, they must be same, right? So when you do that, you will be getting, yeah, you know r1 by r2 ratio, you know r1 plus r2, so you can get r1 value and r2 value, right? A boat crosses a river with a velocity v relative to water, that is constant, relative to water, and perpendicular to the banks. The magnitude of velocity is 0.3, width of the river is b. Speed of the current varies according to the parabolic law. You need to say after how much time it will reach the other end and what is the drift. So this is the given figure. When it has traveled distance x, its speed is always 0.3 perpendicular, right, relatively, and river velocity depends on what is this x coordinate. This is given in the question. River velocity is in this direction and he is trying in this direction, right? Now if you want to calculate what is the time taken, that's like vertical component of velocity is always constant, right? So time taken is width of the river by velocity. So time taken you can get much quickly. Thereafter you need to calculate drift. How to calculate drift? V dt along x axis, right? So V dt along x axis, but what is x? X is varying at a constant velocity, so x is v into t, So I will be putting x equal to v into t, just v into t, and v is 0.3, it is constant. So it's a single variable and integral, so you can integrate it from 0 to 210 seconds, right? So when you integrate it, you will be getting the required answer as 700. Drift is magnitude by 700, right? Position versus time graph of particle as shown in the figure. Select the correct alternatives. Particle does not change in direction of motion during time. X value is increasing and then decreasing, so it's changing, right? Yes, till here it is moving upwards, thereafter it is going downwards. Particle does not change its direction of motion. No, it changes. Particle changes its direction twice during the motion. So from here to here it is going up. After that it started coming down. Again it started going up. So here and here there are two turning points. Yes, correct. Acceleration of the particle changes its direction once during the motion. Acceleration from here to here is in negative x-axis direction, right? Acceleration from here to here is in the positive x. So in this one there is one, it will be in one direction, and here it will be in the other direction. So acceleration is changing only once. Initially it is in one direction, thereafter it is going to be in the other direction. So the change is happening only at once. Direction of force is reversed at t equal to t by 2. Yes, right. From here it is in the positive direction, here it is in the negative direction. Yes. Going to the next question. Heat is supplied to a certain homogeneous sample of matter at a uniform rate. Its temperature is plotted against time as shown in the figure. Which of the following conclusions can be drawn? Yes, I think that's a much direct question. So you can see which time is more. Okay, if I want to compare specific heat capacities, I need to look at these times. Which time is more? This time is more. So okay, not these two I need to compare, right? These two I need to compare, and these two I need to compare. If I want to compare specific heat capacities, I need to compare these two plots where the temperature is increasing, that is, it will be in same phase. So solid phase, in solid phase temperature is increasing, solid to liquid conversion, liquid temperature is increasing, liquid to gas conversion, right? So this specific heat capacity is more, or this is more. It's like ms delta t, right? Now it is taking more time, so the meaning is it is taking more energy, to rise the same temperature, kind of, right? So it is taking more energy, so the more time it takes, the more energy it takes, so more will be the specific heat. So this is more specific heat, this is less specific heat. Now what about this? It is taking less time, it is taking more time. So it needs more energy, it needs less energy. So M into L, this L is more and this L is less. Vaporization L is more and fusion L is less. Right? More. Latent heat of vaporization, latent heat of fusion. Going to the next question, the ring shown in the figure is performing pure rolling on a rigid surface. The radius of ring is r and angular velocity is omega. There are 4 points marked on the ring as shown. After time pi by omega, what is the displacement of A, B, C and D? So when you calculate like V into T, where V is velocity of center of mass, that is r omega, it is pure rolling, right? So center of mass will be traveling a distance of pi r, and angle about center of mass is rotated by pi. Now if you want to look at A, you can look at the motion like motion of center of mass. So this entire thing will travel by distance pi r, and about it will rotate by 180 degrees. So A will travel pi r, and apart from that, due to rotation it will go here, right? So pi r plus 2r, pi r plus 2r, this is the final location, right? So how much is the displacement? That is Pythagoras theorem, right? Pi r and 2r. What is the resultant of pi r and 2r? You will be getting root of, you can see it looks like this, right? Pi r and 2r. Now what about the next one? Displacement of B. Again, when you look at it like motion of center of mass, it is pi r, and due to rotation what will happen? This B will come here, right? So pi r in the forward direction and 2r in the backward direction, right? So pi r minus 2r, right? Pi r minus 2r for B. And what about for C? For C again, due to motion of center of mass pi r, due to rotation about center of mass 2r, pi r and 2r, so which will be same as A, right? Magnitude pi r and 2r. Now what about D? Pi r and due to rotation 2r in the forward direction, right? Pi r plus 2r, right? Going to the next one, a uniform disk of mass m and radius r is kept on frictionless horizontal surface. The figure shows top view. Two particles each of mass m are connected to the disk by two light inextensible strings. The particles are given velocity v0 perpendicular to the length of the strings. Select the correct alternatives just after they are projected. So if you look at free body diagram of the disk, there will be tension on the disk and tension on the disk. By symmetry, I assume both will be equal in magnitude. So net force on the disk is going to be 0. So center of mass of the disk is going to remain there itself. But what about the torque? Both are trying to provide the torque in the same direction. So what will be the net torque? Net torque is this much, that equal to I alpha. From there you will be getting the value of alpha. Now what I know, with respect to this point on the disk, this must be performing circular motion. So I will observe from this point. This point is accelerating, and how much is the acceleration? This much. So when I observe from this point, there will be pseudo force also acting on this. So when I observe from this point, there will be tension apart from that pseudo force. How much is the pseudo force? M into acceleration of this point magnitude wise, but direction wise this way, right? So m into that acceleration is how much? 40. So when I observe from this point, there will be tension T and pseudo force magnitude wise 40. So net force is 5T. 5T equal to mv square by that radius. From there you will get tension, which will give you option D as correct and option C as wrong. And once you know tension, you can substitute it back and you can get alpha, which says option B is correct. Now what is the acceleration of this point? When you observe from, see, now you need to find the acceleration from ground frame, right? So if you want to find the acceleration from ground frame, what you need to do, you need to see how many forces are acting. How many forces are acting? Only tension is acting from ground frame. So F equal to ma, right? So this is the acceleration from ground frame, right? Acceleration from this frame is going to be v0 square by 2r. Next question, in hydrogen atom, the binding energy of electron in ground state is E1, and then frequency of revolution of electron in nth orbit is something. So x and y are integers, find the value of x plus y. So that's like this, right? So E1 is 13.6 given. So in any orbit it will be 13.6 by n square, right? N square. So yes, binding energy is nothing but modulus of the total energy, right? And which is same as kinetic energy when in gravitation or in Bohr's model, you must be knowing. So I can write the same thing as half mv square, Now this is for any orbit I am writing. So half mv square, v is r omega and stuff. I need to bring frequency into it. So I am converting this into this way. But again, r is variable for me, right? So I need to eliminate this. So I am using mvr equal to h by 2 pi. From there, m r square I substituted back. So when I do that, I will be getting the relation between frequency and energy. Energy in any orbit will be given by E1 by n square. So from there you will be getting the required answer. A certain series LCR AC circuit is found that XL equal to 2XC and phase difference between current and voltage is pi by 4. Now the capacitance is made 1/4 and inductance and resistance are doubled, then phase difference between voltage and current is something you need to find what is that. So what they said in the question, series RLC. So when I take current as reference, voltage in the resistance will be in the same phase, voltage in the inductor will be leading, and they said XL equal to 2XC. So I just substituted 2XC and I got this. Voltage in the capacitor will be lagging. Sorry, this is not the right figure. This has to be up, because resultant of these two is going to be in this direction, right? So yeah, this is here. This must be here. Fine. Anyway, if it is 45 degrees, then when you take tan theta, you can easily see XL equal to R equal to XC. Now I will be using that further information. Now in the next case, if I take current as reference, voltage in the resistor will be in phase, and they said resistance is becoming twice. So 2XC. Earlier it was XC, now it will become 2XC, and inductance is becoming twice. So earlier I0 into 2XC, now it will be I0 into 4XC. Now capacitance is becoming 1/4. If capacitance becomes 1/4, then XC will become 4 times of XC, right? Now these two will get cancelled. Now you can see they are under resonance. So under resonance, what is the angle? Angle is 0, right? In the figure shown, arrangement is in horizontal plane. The mass of rod AO is negligible. Whenever something's mass is 0, net force on it must be 0, net torque on it must be 0. It is free to rotate about O. A block of mass M is attached to springs. Springs are light and their stiffness are shown. The block is slightly displaced along the length of the spring and released. It is observed that the block oscillates with the time period. Now what you are doing, this is in the horizontal plane. When you are pulling this, when you are pulling it and you are leaving it, then you are trying to see what is the time period, right? So what is the first thing we are doing? I am pulling it. So this extension I am calling it as X1, and this compression, I am assuming this is getting compressed. Why? The reason is I can show you. Now when I pull it this way, this rod has to rotate it. This rod has to be rotated. If the rod is rotated, then the spring will get compressed. If the spring is compressed, it will try to push it this way. If it tries to push it this way, net torque about this point is going to be clockwise. So there must be some force which must be producing anti-clockwise, only then net torque on the massless rod will be 0, right? Now who is that force? That force will be this force. This force has to push it this way. This force is trying to push it this way, so this force has to push it this way. How can this force can push it this way? Only when it was compressed. When it is compressed, it will try to expand, right? So this extension is X1 and this compression is X2, I am assuming. But what is the total thing? This is expanding by X1, this is compressing by X2, but the total extension is how much? L by 2 into theta, right? This is L by 2. So when you rotate it, the small length is L by 2 theta. What is this L by 2 theta? That is this extension X1 minus X2. So X1 extension minus this compression, right? X1 minus X2 is L by 2 theta. Now the first thing is series massless rod, so net torque on it must be 0. So torque because of this force, this spring force is how much? 2K into X2, right? So L by 2 into 2K X2. L by 2 into 2K X2, that is the torque in this direction, which must be balanced by this torque, right? Because it is massless. So L into this force, L into 3K into L theta, 3K into X, right? 3K into compression. So from there you will be getting the relation between X2 and theta. But what you need to write the force on this. What will be the force on this? This spring will try to pull it upwards because it has been extended, right? So Kx1, and this has been compressed, right? So this will also try to push it in the same direction. So what is the net force? Net force is this much, equals to mass times of acceleration. But what is this acceleration? This acceleration is the rate at which this x is, the double differentiation of this x1, right? So this is x1 acceleration, x1's double differentiation. So I need to convert this into x1, then I can get SHM form, right? So how to convert that into x1? We got one relation. Now apart from that, x1 minus x2 is L by 2 theta. So when I solve it, I will be getting x2 equals to 6 by 7 x1. So x2 equals to 6 by 7 x1, I can substitute. Then I will be getting it like SHM form, right? Once you get it into SHM form, then you can find the time period. So the important thing here is massless rod. On a massless rod, net force must be 0, net torque must be 0. A satellite is describing a circular orbit around a planet of radius r. The altitude of satellite above surface of the planet is 3r and its speed is v0. To place the satellite in an elliptical orbit which will bring it close to the planet, its velocity is reduced from v0 to beta v0. What is the smallest permissible value of beta if the satellite is not crashing? So this is r and it is at a distance 3r from here, right? So totally this is 4r and this is 5r. So if it is performing elliptical orbit, this is the elliptical orbit they mean, right? So what is the length of the major axis? Length of the major axis is 5r. So total energy of the particle which is performing this motion, this elliptical motion, is minus gmm by major axis. Now this derivation is done in revision class also if you don't know how to do it. Energy of the ellipse is going to be minus gmm by 2 times of semi major axis or minus gmm by major axis, right? So now that must be equal to kinetic energy here plus potential energy there. Potential energy there will be minus gmm by 4r. Potential energy plus kinetic energy equal to total energy of the ellipse. From there, when you solve, you will be getting this much. But what was the velocity when it was performing circular motion? It is root of gm by that distance, right? 4r. Orbital velocity. This orbital velocity, you know this value you calculated. When you take the ratio, you will be getting the required answer, right? So the key point for the question is knowing this. 2 point charges q1 minus q are fixed in space at a separation A. The electric flux through infinite plate perpendicular to the line joining. You see, again, it is infinite plate. So if it is a point charge, half of the flux will go on to that side, half of the flux will come on to this side, right? So what will be the flux through passing through? If there is a charge here and if there is infinite Gaussian surface, whatever it is, what is the flux passing through this one? Half of the total flux will pass through this one, remaining half will go to this side, right? So because of this charge, flux passing is q by 2 epsilon naught. Because of this charge, flux passing will be q by 2 epsilon naught, because from here field lines will be emerging out, right? If only this charge is there, field lines will be emerging out. Out of that, half will go through this one, half will go through this part, right? Now forget about this. If there is only negative charge, half of the flux will come from here, half of the flux will come from here, right? So q by 2 epsilon naught will come from here, 2 by q epsilon naught will come from here, right? So if you superimpose, then what you will be getting? You will be getting the total flux passing through this one is q by 2 epsilon naught plus q by 2 epsilon naught. If you want to find the electric field, resultant electric field anywhere, that will be the summation of both, right? So we are superimposing. So the same thing we are looking in a different way. Find the effective value of RMS value. So how to find RMS value? It is root of mean square. So that is, you need to find square root of mean of squares, average of squares. How to find average of squares? Average of squares will be found by this way, right? Now if you find the square root of that, then you will be getting RMS value. Now how to get this? Integral I square dt, you know it is area under I square t graph. So I am plotting I square versus t graph. It looks like this. When you find the area under the graph, that is this area plus this area. That's the only thing coming into picture, right? So when you calculate all these areas and when you add them and when you divide the time, you will be getting 25. That is mean of squares. When you take square root of that, you will be getting root of mean of squares, right? Okay kids, we will be going with the second paper. You can look at the question. Velocity of particle starting from rest is given something. Then which of the following is correct, right? So we can see. So velocity is given. If you want to find acceleration, you need to differentiate it. You will be getting this much. If you want to find the angle between them, you will be using dot product rule, right? So anyway, that depends on time. It seems like there is no way it can get cancelled. So option D is wrong. Angle between them is not constant. It will depend on time. Now what about option A? X component of acceleration is constant, which is 1. Okay. Now particle. Okay, option C, at t equal to 0 acceleration is 0, and substitute t equal to 0 acceleration is not 0, acceleration is 1. Now if you want to see whether it is parabolic or not, what you will be doing? From here you will be integrating it and you will be finding x value and y value, and they said it will start from origin. At t equal to 0, it is x coordinate is 0, y coordinate is 0. From here you will be finding x coordinate and y coordinate. Now you can eliminate time, right? So from here you can find t and you can substitute it here, then you will be getting this equation. This is not a parabolic, right? Y is equals to something into 3 x power 3 by 2. Now going to the next question, consider a region where both uniform electric and magnetic fields are present both along z-axis. A positive charged particle q and mass m is projected from origin with the initial velocity v0 in I cap. So velocity is this way, magnetic field and electric field are in this direction. So if I want to consider only magnetic force, then it is going to be v bar cross v bar, force is going to be in the downward direction. If only magnetic field is there, it would have performed this circular motion, right? But because of electric field, what will happen? The pitch will keep increasing, right? So it will be performing ellipse with increasing pitch. Now after t by 2, after half time, so total time will be 2 pi m by qb, right? So they are asking about what will happen to the after half time. For full time it will perform one circle, but at the same time it must have moved forward also like this. Now if I consider only circular motion, it would have been this for full time. For half time it is like this, right? So y coordinate is minus 2r, right? 2r in the downward direction. So y coordinate, that is correct. And what about the ratio of distances, consecutive points? So it is like in one time period it will reach here, right? In one more time period it will reach somewhere here. In one more time period it will reach somewhere here. So they are asking what is this consecutive distance. So what is this distance? Half into acceleration along this axis into t square, right? So what is the next, what is the distance between next to two? It is, yeah, it's like first touching point is here, second touching point is here, third touching point is here. So what is the distance between first initial point and first touching point? Half a t square. What is the distance between initial point and second touching point? Half a into 2t whole square, right? Because 2 time periods, right? 2 time periods. Now what about the distance between initial point and third touching point? T, t, t. So totally half a into 3t square. Now if you want to find distance between any two consecutive points, half a t square, between next to it is half a into 2t square minus half a into t square. It's like when a particle is dropped, then how you will find distance traveled in second. It is distance traveled in 2 seconds minus distance traveled in 1 second, right? From there you will be getting option B as correct, option C as wrong. The maximum x coordinate. Now it will be performed circular motion, right? If I neglect helical motion, if I neglect the pitch, it will be performing circular motion. Now what is the maximum x coordinate? Maximum x coordinate is only r, but they said it is 2r, right? Two identical strings of mass m and length l are connected on ceiling of a lift as shown. Two wave pulses, one at the upper end and one at the lower end, one at the upper end of string 1 and one at the lower end of the string 2 are produced simultaneously. The lift also starts moving from ground upwards with a constant acceleration. So you need to find some stuff there. So first of all, the thing is v equals to root of t by mu. This is speed of wave with respect to the medium. That is speed of wave with respect to the string in this particular case. Now one pulse is generated here, one pulse is generated here. What is the tension here? Tension here is 0, the speed is 0, but that speed is going to increase with the time. What about the speed here? Speed here will be root of t by mu. Now what is the tension there? When I am going on to the lift rem to see the things easily, because I can calculate tension easily. At the same time, the speed is with respect to the string, that is with respect to the lift, right? So I am sitting on lift rem. So tension is going to be m into effective g, m into 2g. So here tension is maximum, but what will happen? The velocity will keep on decreasing, right? Tension will keep on decreasing, velocity will keep on decreasing. So what does it mean by velocity is keeping on decreasing? Acceleration of the wave is going to be in the upward direction. What does it mean by velocity is increasing? Acceleration of this wave is in the upward direction. So both accelerations are in the same upward direction. Now if I want to find this acceleration, what I will be doing? I will be differentiating its velocity, right? What is its velocity? Root of t1 by mu. Now if it is at a distance x1, then the velocity is going to be, tension is lambda into x1 into, this has to be L minus x1. This has to be L minus x1. I think this has to be L minus x1 and the other one has to be x2. So this has to be L minus x1. So anyway, if you differentiate it, it will turn out to be something like this equation. So finally you will see that L minus x2 or L minus x1 doesn't matter, it will be getting cancelled. So tension here will be lambda into L minus x1 into 2g. Here it will be x2 into 2g. So interchange them. Anyway, you will be getting acceleration as g. I will be worried only about magnitude because I have seen the physical significance. This acceleration is in the upward direction, this acceleration is also in the upward direction, right? So acceleration of the wave with respect to the lift is g upwards. So with respect to ground, it is going to be g plus g, which is 2g upwards, right? So option B is going to be wrong, option C is going to be correct. But this has to be x2, this has to be L minus x1. Now after getting those two options, both wave pulses with the same will be at the same horizontal level. The meaning is you need to observe these two, right? So you can sit on one pulse and you can observe the other pulse, right? Both accelerations are same g in the upward direction, right? Or 2g. With respect to ground, it is 2g upward direction, right? So relative acceleration is going to be 0, relative velocity is v, and relative displacement is L. So from there you can calculate time is going to be option A. Now in that time how much distance lift will travel? Half A into T square, right? So that will give you option 4. Heater 1 takes 10 minutes to increase temperature of liquid of mass 2 kg by 20 degrees when connected with 200 volt supply. Heater 2 takes 20 minutes to increase temperature of liquid B of mass 4 kg by 20 degrees when connected with 400 volt supply. So in the first case they said liquid A mass 2 kg, temperature change 20 and specific heat capacity 6000. So what is the energy needed? Ms delta T, Ms delta T, which is 240 kilo. Now this much energy from where it has got? From the first heater whose power is P1 and time is 10 minutes. 10 minutes is 600 seconds. So what is the power of the first thing? Power of the first thing is 400. Now similarly I can get the power of the second one is 800. Ms delta T for second liquid, right? That must be equal to power into time by the provided by the second heater. Now what is this power? How to get this power? V square by R, right? Because V they have given V square by R. When you do that, you will be getting resistance of the first one is 100. Similarly, resistance of the second one is 200. Now when you connect them in series, then what will be the power? V square by total resistance is 300 into T. This is power into T. Now that equal to Ms delta T. Ms delta T, where then you will be getting T as 1200 seconds, because they are saying first liquid by 30 degrees, 2 kg, 30 degrees, 600. Now in the fourth option they are saying when they are connected in parallel, that is V square by R1 into T first energy, V square by R2 into T energy by the second heater, that equal to Ms delta T. Ms delta T for the second liquid, right? So from there you will be getting time is 960 seconds, which is option D is also correct. A single conservative force acts on a particle, moves along x-axis. The graph of potential energy with x is given at x equal to 5 meter. At x equal to 5 meter, kinetic energy is given, and its potential energy you can find by substituting in the equation. So you know what is the kinetic energy here and potential energy here. So you know the total energy. So how to get that energy? So total energy is kinetic energy here plus potential energy there at x equal to 5. So that's the total energy, which will be 69. From there you will be getting option A as correct. If option A is correct, option B is wrong. And about option D, the maximum value of kinetic energy is okay, C and D, right? Okay. So at C it is going to be okay, option C, at x equal to 3 kinetic energy is going to be maximum, because potential energy is minimum, kinetic energy is maximum. So option C is wrong. The maximum value of kinetic energy, what will be the maximum value of kinetic energy? That is total energy is 69, but minimum value of potential energy is 15. So 69 minus 15, that is the maximum kinetic energy, right? 69 minus 15, so that is going to be 54, right? Two blocks A and B of equal mass initially in contact when released from rest. The coefficient of friction between, okay, is given. Tan theta is greater than mu1 and tan theta is greater than mu2, that is sin theta is greater than mu mg cos theta. So that is they are sliding. So they give tan theta is greater than mu, so that to say like if there is only one block placed, then it will slide. It will slide. Mg sin theta is sufficient enough to slide it. Now what you need to do is, okay, assume they are placed far away, little far away. Then what is going to happen? Whose acceleration will be more? That depends on mu1 and mu2. If mu1 is greater than mu2, then what will happen? A's acceleration will be less and B's acceleration will be more. So the meaning is, if you place them side by side with a small gap, if mu1 is greater than mu2, what will happen? A will slide slowly, but B will slide quickly. What will happen? Then B will come and touch it, right? So normal reaction will be there. So if mu1 is greater than mu2, normal reaction will be there. But if mu1 is less than mu2, what will happen? A will slide faster, B will slide slower, so there won't be any contact. So A will slide independently and B will slide independently, right? So if this friction is more and this friction is less, this will slide slowly, this will try to slide quickly, and it will come and hit A, right? So there will be normal reaction. Normal reaction between them won't be 0. From that, what we can get? The blocks will remain in contact. Yes, option A is correct. Now option B, Yes, if it is less, then both will slide with different accelerations. We understood it, right? If A is moving quicker and B is moving slower, they won't be in touch anymore. So they will have different accelerations. What is that acceleration? That is mg sin theta minus mu1 mg cos theta by mass of that for A. For B, similarly, both mu's are different, so both accelerations will be different. Now, if you want to find common acceleration in this case, when they are moving together case, if you want to find the common acceleration, net force, what is the net force? Both mg sin theta minus mu1 mg cos theta minus mu2 mg cos theta equals to total mass into acceleration. So that is not matching with the given option, right? Next question. The pitch of screw gauge is 1 mm and circular scale is divided into 100 divisions when nothing is put between the studs of the main scale. Okay, 0 of the main scale is not seen. When the circular scale is rotated by 450 degrees, 0 of the main scale is just visible and 0 of the main scale coincides with the 0 of the circular. So what you need to do, you are rotating it by 450 degrees, that is how much? One full rotation plus 90 degrees, that is 125 divisions, 125 circular scale divisions. So when you are rotating it by 450 degrees, what is happening? Then it is looking like perfect scale, right? So if you put an object of that much length, okay, let me say how much we have rotated, that is for 360 divisions it will move by 1 mm, right? So for 450 for 360 degrees it will, for one full rotation it will move by 1 mm. So for 360 degrees it will move by 1 mm. So for 450 degrees how much it will move by? It will move by 1.25. That is, if you keep an object of this much length, what it is going to show? It is going to show you 0, because they said main scale 0 and circular scale 0 is also coinciding, right? So it is showing 0, but actually how much is the length of the object we put? It is 1.25 mm. Actual length is 0, but if you want to get the actual real value, then you need to add 1.25. If you want to add 1.25, the error we are going to say is negative error. So the error is negative, and in magnitude wise it is 1.25 mm. Now if you want to find the thickness of the plate, they said some other thing. So initially you rotated by 1.25 mm, then it looked like normal scale. From there, how much you are moving? You are moving it by 18 mm, because 18th division is visible, they said. Apart from that, 34th division of circular scale is coinciding. So 34th division. So for one division it is 1 by 100 mm. For 34 divisions it is 34 into 1 by 100. When you add all of them, you will be getting the required answer, right? And the next question, this already appeared in one of your previous exam, right? So it goes like this. Center of mass will be fixed and this distance is 4r by 3 pi, this distance is r minus 4r by 3 pi, this is r, this is r. Now when you heat it, it will expand as if like photo is just zooming, right? But with center of mass fixed. So this will expand, this will expand, this will expand, this will expand, right? Now from there I think we can get A along y axis, it will expand, new length will become, it will expand by r alpha delta t, right? What about x axis? It is 4 alpha by 3 pi into delta t. The center line will shift this way, right? Which is 4 by 3 r by pi delta t. So option A is correct, option B is correct. B along x axis is r alpha delta t. No, that is this length into alpha delta t. So C is wrong. B along y axis is 0. Yes, B is not moving along y axis. The next question, a physical quantity is given. Percentage error in calculation of P you need to do. So that's the same algorithm. So you'll be taking logarithm, you'll be differentiating it, and you'll be finding the maximum error. Yes, it's only about substituting the values and getting the answer, right? A current carrying string in the shape of a ring is placed in uniform magnetic field. The current and area of section are given. The density of the strings, the speed of the wave, find the magnet. See, now if I take any small element, what will be the force on that? V bar cross L bar cross P bar, this way, perpendicular to the element. So if I take half the ring, half of the ring, the force on that half ring is going to be this way, just like surface tension force, right? So the resultant of all this will be in the horizontal direction. Now how much is that force? That force is I into effective length into B. Now who is balancing that force? That force will be balancing by tension in the string, 2T, right? So by drawing half the ring we can avoid integration because we know the well known results. right? So tension is this. So this is the net force equal to 0 equation for half string. From there you will be getting tension. Once you get tension, you can find the speed and you can square it, because they have given all the values and they asked you to find magnetic field. The only critical thing is drawing half the ring and seeing surface tension kind of force. Initial AC is open and capacitor A is charged up to potential V by 2 and B is uncharged. After closing the switch, heat loss in the circuit. So how it looked initially, it looked like this. When you close the switch, what will happen? This charge will change, this charge will change. Okay, let me say this charge is Q1, then this will become minus Q1. Let me say this charge is Q2, this will become minus Q2. When I write, yeah, this was closed. When you write the loop equation, you will be getting this much. So minus, yeah, so you will be getting loop equation as this much. But what you know, these two plates are isolated. These two plates are isolated. So charge on it must remain same. How much is the charge initially? Minus CV by 2. Minus CV by 2 equal to minus Q1 plus Q2. This is from isolated plates charge conservation. This is by loop equation. When you solve it, you will be getting Q1 and Q2. When you substitute it back, it looks like this. Then you can see there is a change in energy. Now what is the work done by the battery? Work done by the battery is how much is the charge given by the battery. Earlier on this plate it was CV by 2. Now on this plate it is 3 CV by 4. So what is the charge given by this battery? It is giving CV by 4. So what is the work done by this battery? CV by 4 into V. Out of this work done by battery, how much is going as change in internal energy of the capacitor? That is this internal energy plus this internal energy minus initial internal energy. This is the change in internal energy of the capacitor, and the remaining will go as heat. When you calculate heat, you will be getting the answer, right? Now the next question figure shows variation of internal energy with the density of 1 mole of ideal diatomic gas. Rectangular hyperbola, they said. So if the work done is W, then what is the W? So they said U into rho is constant rectangular hyperbola, and you know PV equal to nRT. From here, N you can write it as M by capital M, right? So when you take volume that side, you will be getting density. So rho by, when you take this temperature this side, you will be getting P by T. P by T is proportional to rho. So instead of rho, I will be putting P by T, and instead of U, U is NCVT, right? Instead of U, I am putting T. NCV I am not putting the constant, I am just putting the what are the variables. So from here I can understand it is pressure equal to constant, like some constant, some other constant, some other constant. So finally pressure is constant, I understood. If pressure is constant, then what is the work done in isobaric process? Integral P dV, which is P delta V, which is nR delta T. They are asking you to find this, but they have given this information. NCV delta T is 37 minus 2 according to the figure, right? What is CV for diatomic gas? 5 by 2 R. Number of degrees of freedom are 5, right? 5 F by 2. So from here nR delta T will be how much? 14. The density of solid spherical planet of radius capital R is given. The acceleration due to gravity is half of maximum value at a distance x from the center and y from the center. So maximum value will happen on the surface, right? Maximum value will happen on the surface. So you will find 1 point inside and 1 point outside, where it will be half. So first of all, what is the thing I did? I found mass as a function of radius. So I have taken one spherical element and I found the mass of that spherical element, and I integrated from 0 to r. I got mass as this much, that is mass inside radius small r. So if I want to find the maximum value, if I want to find the field of the maximum value, okay, how it looks, okay, let me draw the figure. So let me say this is radius r. Now maximum value will happen here. If I want to find the maximum value here, it is G into mass enclosed by that radius square, right? G into mass enclosed capital R, right? Mass enclosed by capital R. So this is the maximum value. Half of the maximum value is this much. Now if I am talking about inside, if I want to find the field inside, then what will be the field there? That is G into this mass enclosed by this radius square. G into that mass enclosed by that radius square, small r square. Now if I want to talk about the field here, now then you will be getting G into mass is only this red color one, right? G into mass enclosed by this radius square, right? In this case both are going to be different, but in the case of purple thing, both small r, these two r's will be same, right? So if I want to find the field here, G into this mass by this radius square. If I want to find the field here, G into red color mass by this distance square. And they said this is equals to half of the maximum value. This is inside and that is outside. When you do that, you will be getting one value inside is this much, one value outside is that much. They are asking what is the addition. A uniform vertical cylinder is released from rest when its lower end touches the liquid density. Yeah, what is the maximum displacement of the cylinder, right? So when you leave it, what will happen? Gravity will try to pull it down. When it is pulling it down, some of the volume will be submerged inside, so there will be buoyancy, right? Now the good thing is the buoyancy looks like this. When a distance x is submerged, then the buoyancy looks like density of the liquid into volume submerged into g. When I manipulate it, it looks like some constant into x form. That is like a spring force. Buoyancy is behaving like a spring force, right? So now I can visualize like a spring is connected whose spring constant is this much. Then what will happen? Work done by gravity, if it is converting as potential energy in the spring, then it will come to rest, right? So work done by gravity is converting as potential energy in the spring. That's what I am using. Half kx square. mgx equal to half kx square. So from there I will be getting x value is this much. That is where it will be going to stop, right? I think this value, it will turn out to be 1 according to the given question. So L value is 8.02. So I went with work energy theorem and comparing buoyancy force to spring force. In the next question, if the photons of ultraviolet light, okay, 12 volt, work function is 4. So what will the maximum kinetic energy? Maximum kinetic energy will be 8 electron volt. So what is the stopping potential? 8 volt. So option P. Okay, the next one, K alpha. Okay, we'll go to K alpha later. So going to the third part, 20 gram is converting into 10 gram in 4 minutes. That is half time is 4 minutes. 80 gram will be converting into 20 gram in how many minutes? It is like 80 gram will become 40 gram in 2 minutes, 40 to 20. So 8 minutes, right? So third one is 8 minutes. What about the next one? Mass defect of nucleus of helium is given. Helium, that is there will be 4 nucleons. So per each nucleon, how much it is going to be? 0.0302 by 4 into conversion is 930, right? So I think these are all direct only, by 4 into 9. Now what about the next one? In case of K alpha, what will happen in K alpha? So there will be space in first shell, K shell, so which will be occupied by the electron in the immediate shell, right? L shell. So electron from the L shell will be coming into the K shell. While it is coming, what will happen? It will be experiencing a total charge of the nucleus and one electron which was already present in the. So if this is the nucleus and this is the first orbit and this is the second orbit, one electron will be coming from second orbit to the first orbit. But while it is coming, what it will experience? It will experience this total charge as well as one electron which was already existing in the first orbit. So the total charge experienced by it will be Z minus 1. So the equations will look like energy equals to some, in Bohr's model of hydrogen, this used to be 13.6. So something like that you will be getting, right? Constant into z square into 1 by 1 square minus 1 by 2 square, right? Second orbit to first orbit. But the only difference is instead of z, we will be putting z minus 1 because it will be experiencing effective charge of z minus 1. That's what Mosley said, right? So from there you will be getting 1 is 86, you will get z minus 1 is 85, z minus 1 is 81. So 86 and 82. Between 82 and 86, 83, 84, 85, 3 elements are there, right? Going to the next question. I think it's pretty much direct. When the source is at rest, wavelength won't change. When the source is at rest, wavelength won't change. No, wavelength won't change here. Wavelength will change here. Okay, wavelength can change here because wind is there, right? Wind is there. So what you can do in all these cases is, frequencies you must be knowing. Like source is at rest, but this observer is moving away, so this frequency hertz will be less. This frequency hertz will be more. Source is moving towards, so this frequency hertz will be more. This frequency hertz will be less. So frequency things you can calculate, those are direct questions, right? Only wavelength is the problem. In all wavelength questions, what you can do, you can visualize it this way. Source like dropping balls. If source is stationary and dropping balls of speed, let me say 330, that is speed of sound in air, right, with respect to medium. Now after some time this will be moving forward. Now you will be dropping another ball. So this is the distance between two consecutive balls or two consecutive compressions or rarefactions. That is the wavelength, right? So I think all the answers you will be getting by visualizing that way. So you can visualize sound or crests or compressions or rarefactions like the balls dropped by source. Now speed of the ball is going to be 330 in normal case, but if wind is flowing this way, what will happen? It will become some 330 plus, let me say speed of wind is 10, then it is going to be 330 plus 10. But if a observer is on this side, okay, let me do this thing. If I talk about some ball which is going in the backward direction also, so that is 330, right? Now if wind is blowing in this direction with speed 10, then this velocity will become 10, this velocity will become 340, this velocity will become 320. So you can see the wavelength pursued by the other guy who is there will be different from the wavelength pursued by this guy, right? So you will get all the options from there. If you want, you can try by yourself. Now this is what you will be getting. In option 1, wavelengths will be same. This is the relation between frequencies. If you want to try by yourself, exactly. So everything will be getting by the same thing, same reason. So first of all, get the frequencies, because you are comfortable getting the frequencies, then try for wavelengths, right? Thank you.